How is gold formed? Origins and process. Gold is a chemical element easily recognized by its yellow metallic color. It is valuable because of its rarity, resistance to corrosion, electrical conductivity, malleability, ductility, and beauty. If you ask people where gold comes from, most will say you obtain it from a mine, pan for flakes in a stream, or extract it from seawater. However, the true origin of the element predates the formation of the Earth.
Key takeaways. How is gold formed? Scientists believe all the gold on Earth formed in supernovae and neutron star collisions that occurred before the solar system formed. In these events, gold formed during the R process. Gold sank to the Earth's core during the planet's formation. It's only accessible today because of asteroid bombardment. Theoretically, it's possible to form gold by the nuclear processes of fusion, fission, and radioactive decay. It's easiest for scientists to transmute gold by bombarding the heavier element mercury and producing gold via decay. Gold cannot be produced via chemistry or alchemy. Chemical reactions cannot change the number of protons within an atom. The proton number or atomic number defines an element's identity.
Natural gold formation. While nuclear fusion within the Sun makes many elements, the Sun cannot synthesize gold. The considerable energy required to make gold only occurs when stars explode in a supernova or when neutron stars collide. Under these extreme conditions, heavy elements form via the rapid neutron capture process or R process.
Where does gold occur? All of the gold found on Earth came from the debris of dead stars. As the Earth formed, heavy elements such as iron and gold sank toward the planet's core. If no other event had occurred, there would be no gold in the Earth's crust. But, around 4 billion years ago, Earth was bombarded by asteroid impacts. These impacts stirred the deeper layers of the planet and forced some gold into the mantle and crust. Some gold may be found in rock ores. It may occur as flakes, as the pure native element, and with silver in the natural alloy electrum. Erosion frees the gold from other minerals. Since gold is heavy, it sinks and accumulates in stream beds, alluvial deposits, and the ocean. Earthquakes play an important role, as a shifting fault rapidly decompresses mineral-rich water. When the water vaporizes, veins of quartz and gold deposit onto rock surfaces. A similar process occurs within volcanoes.
How much gold is in the world? The amount of gold extracted from the Earth is a tiny fraction of its total mass. In 2016, the United States Geological Survey, USGS, estimated 5,726,000,000 troy ounces or 196,320 US tons had been produced since the dawn of civilization. About 85% of this gold remains in circulation. Because gold is so dense, 19.32 grams per cubic centimeter, it does not take up much space for its mass. In fact, if you melted all the gold mined to date, you'd wind up with a cube about 60 feet across. Nevertheless, gold accounts for a few parts per billion of the mass of the Earth's crust. While it's not economically feasible to extract much gold, there are about 1 million tons of gold in the top kilometer of the Earth's surface. The abundance of gold in the mantle and core is unknown, but it greatly exceeds the amount in the crust.
Synthesizing the element gold. Attempts by alchemists to turn lead, or other elements, into gold were unsuccessful because no chemical reaction can change one element into another. Chemical reactions involve a transfer of electrons between elements, which may produce different ions of an element, but the number of protons in the nucleus of an atom is what defines its element. All atoms of gold contain 79 protons, so the atomic number of gold is 79. Making gold isn't as simple as directly adding or subtracting protons from other elements. The most common method of changing one element into another, transmutation, is to add neutrons to another element. Neutrons change the isotope of an element, potentially making the atoms unstable enough to break apart via radioactive decay. Japanese physicist Hontaro Nagaoka first synthesized gold by bombarding mercury with neutrons in 1924. While transmuting mercury into gold is easiest, gold can be made from other elements, even lead. Soviet scientists accidentally turned the lead shielding of a nuclear reactor into gold in 1972, and Glenn Seaborg transmuted a trace of gold from lead in 1980. Thermonuclear weapon explosions produce neutron captures similar to the R process in stars. While such events are not a practical way to synthesize gold, nuclear testing did lead to the discovery of the heavy elements einsteinium, atomic number 99, and fermium, atomic number 100.